Wonderful. Good morning. Folks are doing well after Autodesk. I could not make it to Autodesk last night, but I am. I'm glad that you guys are here. I'm glad that I'm here. This is my first time in Portland and Teardown. I've heard so much about it, and this is like a fantastic group of people to be presenting to be interacting with, and I feel like. So many of you, I feel like I have seen your work online, and being able to meet you in person has been incredible. And so many of you are also Portland native, which is amazing. All right, so today I'm going to talk about the thing I love to do is building circuit sculptures, building circuits without circuit boards. And I gave a similar talk back in 2019 at SuperCon in Southern California. And this is an updated talk to that, like the things I've done in the last few years and the updates I've made to the art form. If you're confused how to spell my name, it's Mohit Bhoite, just so you know. My day job is I am a hardware engineer at Particle. I have been working at Particle for about 11 years now, helping design most of their hardware IoT products. This talk is also sponsored by Particle. You will find a $20 gift card in your tin box. And so you can use it for anything you want to buy at Particle. It could be a T-shirt, or it could be a microcontroller, to suit your needs. So I helped design the Boron, which is a cellular connected IoT dev kit. So that's what I do as a day job, designing circuit boards. But then, of course, I need to keep my mind occupied. So on weekends and weeknights, I will spend time building things using the stuff I do at work. It's a blessing to be able to work for a company that I actually enjoy working for, and then go back home and work some more using the same things you do at work. So I'm going to talk today about these sculptures, but I'll talk a little bit of the history. I'm a 90s kid, and I feel like the Teardown also has a 90s vibe to it. I asked ChatGPT to make me a 90s theme slide, but it somehow got the Tamagotchi spelled incorrectly. I don't know why. So don't blame me. So Beam robotics. I was chatting with somebody this morning about Beam. How many of you are aware of this concept, Beam? Ooh, more than one. Awesome. And so I got started. Growing up as a kid in Mumbai, India, I read this article about Mark Tilden, the guy who trains his own robots, was the theme. And the idea was he would make seemingly intelligent creatures out of discrete electronic components, not microprocessors, no microcontrollers, simple logic gates, resistors, capacitors. And that allowed me to dabble in electronics without having to invest a whole bunch in PCB manufacturing or like having an exotic soldering station. Literally breaking apart Walkman players to get motors and circuits allowed me to get into this hobby. I build robots, and I have been always fascinated by taking pictures of the things I do. So this is me thinking with the point and shoot. The picture is crisp, but it wasn't, but still. That was one of my first Beam robots, but then I went to school, learned more about electronics, and started to use this free-form way of making circuits. I took a break, and then I picked it up again in 2016, where I'm like, I feel like I can give Beam robotics another try. And instead of using Beam circuits, I started using this stuff I was building at Particle, which is Particle Photon, Photon 2, to make these objects. And I kept going down the path of what can we do? How can we push this art form to do more? And so I kept building it, and then it just one thing leads to another, like reimagining what you already know about using 555 timer blinkies, but instead of on a breadboard, on a circuit board, it's actually a living, breathing sculpture. I did all of that, and then I went down this rabbit hole of space theme. And who doesn't love space? Like spacecraft, satellites, landers, all of that. And I started, evolving that idea through successive projects. And I landed on the idea of wanting to really harness this this particular segment of what could be possible with freeform. And so I built a lot, and that's what I wanted to talk about today is like space-themed circuit sculptures. But can anybody tell me like what makes space theme an ideal like choice for this art form? Yes. Exactly. It has a lot of exposed circuitry already. And space is extremely constrained. Like you can't just like send as much stuff as you want. It has to be extremely, extremely lightweight. So only the essentials make it to space. All of the other things fall apart. And so if you look at space stations or satellites, they already look like sculptures in their own right. They have solar panels, they have trusses, landing pads. All the panels are exposed. Sometimes they'll obviously have radiation guard against them. But it's just waiting to be transformed into an actual living, breathing, tiny little life form. And so I went back to the roots of using logic gates. These are called pummers. It's an interesting word. Pummer is a circuit that lives within the beam ecosystem. The idea is you have a solar panel, you have a little solar engine, which is a circuit, and an LED. So the idea is this beam pummer will charge all day, and as soon as it's dark, it will start to pum. So it will give bright flashes of light, just like a firefly. And so the idea is this is a night creature that eats all day and then blinks in the night. And so again, it feels like it was a natural transition from like using solar panels, using LEDs, and just reimagining that in a satellite shape or form. And then why stop at discrete electronics? We live, in the future right now, so better use microcontrollers. So I tried to see if, could I use low-power microcontrollers to actually, reimagine, landers or satellites. So this is two variations using the same exact microcontroller, which is an ATtiny. Solar panels, a supercapacitor, and a diode. No exotic charging circuitry or complicated, power management. It's simply a diode connected to a solar panel, and that feeds a supercapacitor. And this, on a full charge, will last about 3.5 to 4 weeks. And I have two of these at one of these shelves here, so please take a look. And then I said, okay, what if I did not want to use something that was, power efficient? So why not go to some exotic bubble 7-segment displays? Have you seen these tiny bubble segment displays? They were used in Texas TI calculators back in the 70s. Really, really cute. And I adore them because, and funny side story is I lived in Minneapolis, there was an surplus store, and I found a tiny little drawer, they had 50 of them. And I obviously bought all 50 for $20. They are expensive, and so I'm like my precious. I'm hoarding all these electronics. And so I love using vintage electronics in a modern representation of circuits. So 7-segment displays, bubble displays are I love using them. Also using LEDs or RGB lights. Being able to use, again, regular available components to make something that is more, interesting to look at, interesting to put on your desk. I have the one that is on the left. It's a thermometer, but that obviously shows temperature in binary. And when it's not showing temperature in binary, it goes through different flashing patterns, because why not? We all love blinkies. The sculpture on the right is actually a VU meter, which is a noise level or audio level meter. They used to have this in old cassette or boom boxes, where it shows the light level. And so it's using a simple ATtiny with a microcontroller, a microphone that does ADC conversion and then maps it onto an RGB light array. So fun little object powered by a coin cell. I also then started to actually put microcontrollers that have radios in them in my sculptures. So both of these sculptures are built around a tiny little dev kit called Xiao BLE by Seed Studio. I love this form factor. Adafruit also makes these, they call them Qt Pi. This one uses an NRF 52840 BLE chip. And the most fun thing is this satellite, which is orbiting a trail, it actually is transmitting BLE beacons that are captured by the lander, and there's no pairing. So the satellite is actually talking to the lander in the same room. So you could imagine like having multiple satellites in different parts of your room or a house, hanging by a window, and then they're actually transmitting data to your little lander that sits on your desk. So just being able to use radios, lights, and having them talk to each other. But then why stop at space? Space could mean many things. And so I, again, an avid fan of Star Wars, and so I build these bedside clocks that are inspired from, can anybody name the spaceships, possibly? Sorry? TIE fighters, yes, and a TIE interceptor. So I was like, the wings basically don't obviously have any function, but they do provide the function of supporting the sculpture. And so you don't have to build landers or satellites that are based in reality. You can take inspiration from exotic science fiction movies or novels or ideas to build these sculptures and still be in the space theme. This is the latest generation of landers that actually uses a particle photon too. And the idea is it's a widget that sits on your desk, but it's internet connected. And that means I can be displaying, when's the next SpaceX rocket launch, or how's the Bitcoin doing, or not doing, or using that web.gov to fetch weather forecast for the location that this lander is. So right now it's programmed to fetch weather data in San Francisco. And so I can actually, this is all like free services. And being able to now talk to the internet now gives more power to my sculpture. Now I can use it more than just a bedside clock. And again, you can see how this is just smoothly transitions into the whole lander space, because that tiny little cylinder could be a fuel tank, but it's a tiny little lithium battery, made to look like a fuel tank. All right, so what does a typical process for building these sculptures look like? So I did give a talk in detail before, so I don't want to repeat. And also, all of these sculptures are documented on my website, so I try to take as many pictures as possible. All the schematic and codes are open source. And so we will not dive deep, but we'll just take a bird's eye view of what that looks like. But before that, I need to lay some ground rules. But please understand, these are just the rules that I defined for myself, and this should not be taken as a fact. But allowing or putting constraints on the way you approach this art form helps you become, I think, more creative. One of the first things I do is not to use any electronic component that doesn't serve a function or purpose in the circuit. And so it's like the engineer in me battling the artist in me. I'm like, oh, but a capacitor would really look cute as yours. I'm like, no. You could, unless it's, you can use that as a bypass capacitor, but not just put it and short it there. So that's one rule. Second rule is using solder as the glue. So each and every joint should be put together with solder as opposed to glue or a thread or something else, because that really pushes you to think in terms of using solder as a media and not glue. And the third one is, these are not facts, is not using wires unless you're working with a moving assembly or bringing power to the sculpture. So I try to avoid wires as much as I can and use brass rods or copper rods instead. Bless you. And then I do schematics, obviously, and try to document them as much as I can. So first thing you do is draw a schematic either with a pen and paper or with Fritzing or Eagle or KiCad, whatever your medium is. And then I like to breadboard them. This is an easy to miss step, because people are like, oh, I have build this 555 timer like bazillion times. Like, why would I need to breadboard it? But no, breadboarding really helps lock down the design. Sometimes there is feature creep that happens. Like I wanted to put a GPS receiver on one of my sculptures, which looked great on a breadboard, but didn't quite pan out on the sculpture. And so being able to test, refine your ideas on a breadboard before you actually move on to a sculpture is a simple and easy step. I make paper templates. You could use 3D printed templates, but simple two-dimensional printed template goes a long way. So these can be sketched in any of your favorite CAD program. These were sketched in Autodesk Eagle, but you can use Inkscape, you could use Adobe Illustrator, you can use KiCad. So dimensionally scaled, templates. And then I use these templates to then bend the sculptures, but yeah, the tools, sorry. Very simple tools. Yes, standard soldering station, greater than 50 watts. Anything less will have trouble melting the solder on these thick gauge wires. Flux on every single joint, and then brass wool to clean your tip after every single joint. Otherwise, those crusties, you don't want the oxide crusties on your joints. And so, quick tip on that. I use simple flat needle nose pliers and diagonal cutters. Most of you probably already have this. If not, these can be bought either on DigiKey or a jewelry store. So nothing exotic, very simple components. And then I have found these angle plates to be extremely useful to align the components to a more 90-degree angle, and a masking tape to put everything together. You'll see an example here now is how you can simply use those pliers and tools to match the bends on a paper template, put it down on a masking tape, and then solder them together. But again, remember to put flux on every single joint. And then, easy peasy. In 2 weekends, you can have a sculpture of your own. And then software. I mean, I'm at a very safe space here to admit, to me, software is a means to an end. And thanks to AI, you don't even have to write your own software. And so, the powerful thing about, again, this is me talking about Particle, it makes your job very easy because we have built-in webhooks. And so webhooks are actually going and fetching the data for you, parsing it for you, and just simply sending the essential things to your device. So you're not doing any parsing on the device side. And it's all free. And so I use Particle, but you could use ESP32s, you can use Picos, Raspberry Pis, whatever suits your needs. But know that adding connectivity to a sculpture takes it a very long way. And so I have built 3 generations of these sculptures now, starting from a simple Bluetooth, a Wi-Fi, and a cellular based. The cellular based is the latest idea that you could have a sculpture anywhere there's cell phone connectivity and still have access to the internet and fetch interesting data. Again, all of this is documented, so if you wanted to build this on your own, the information is out there. And one last thing, when in doubt, just add legs. You could turn any electronic circuit board, a module, into a space-themed sculpture by simply adding legs. So literally, I took my older sculptures and just added legs, and now voila, I have landmarks. I think that's it for my talk. Thank you. Thank you. If you have any questions, I am happy to answer them right now. I'm here until 5 today, so we can be talking then. Yes?
Can you go back to the slide with the solar power?
Oh, yeah.
Like slide number 8.
Solar power, let's see. Was it this?
And then repeat how long it lasts.
This one, this pummer?
Yes.
This pummer depends on your supercapacitor. So this one will last anywhere from 20 minutes to 2 hours. Yeah.
Where's the one that lasts 3 weeks?
Oh, yes, 3 weeks.
And where's the schematic for them?
So the schematic is on my website, if you look. It's a very simple circuit. It's 2 solar cells in series connected from it with a diode to a supercapacitor.
Can I just give you a block?
Just. Yes, sir.
Have you made a lander that topples over?
Topples over?
Yeah.
I mean, yes, I have. I have. Thanks, ISRO, but yes.
Do you have any problems with the tape melting? Do you ever use Kapton tape instead? Or when you're actually putting it together, do you tape each portion down?
I tape each portion down, and yes, the tape will melt a little bit, but you're so quick with the solder joint that the heat doesn't travel as fast. But if you're using copper, then the heat travels faster, and so you have to be more careful. But brass is pretty forgiving. right? Any more? Oh, yes, sir.
Any plans to make a plane?
Plane, yeah. Planes are boring. They're too real. Yeah. Yeah, drones could be fun. Yeah, like using like the same idea of creating like a frame for your drone and just putting motors around. Yeah. It, yeah, totally. Yeah. Yes. Oh, plenty of time.
Just simple question. Where do you keep these in your house, all of them?
I know. I live in a tiny apartment in San Francisco, so these are just like on bookshelves. I don't even like have glass cover, and I have 2 cats. And so, like my use of AI today is removing cat hair from my photographs, basically. And so they're all covered in dust, covered in cat hair, unfortunately. And the marine air doesn't help either. But you can see the copper has been oxidized. It has, has a patina on it now, but it adds to the character.
First off, the fact that you told us stories about what you were building just really explains why all of your sculptures make sense. Because you actually, they're not just, oh, this would be cool going together. The fact that you have a purpose for each one of them. Thank you very, very much for sharing that. And then just something simple, where do you get all those little copper circles for the landing feed?
Like the copper?
Yeah, for the landing feet.
The circles.
Oh, yes. So I have a link on the website, too. I used to punch these discs using like a jeweler punch, but it makes too much sound, and it doesn't always create crisp discs. So I found an Etsy store. There's this lady in Hong Kong that sells it for $2 for a set of 100 discs. And so it's very convenient. It's a problem solved. But they are only available in brass. I asked them if they could make it in copper. They said no. So copper, I still have to make it myself.
Any other questions?
Yes, all the way back.
What is the balance between having many prototypes or fixing the existing sculpture until it's good enough for you?
There have been instances where ideas have not panned out, and so instead of going down the rabbit hole of trying to actually recover the sculpture, I just give up on the idea. But fortunately, if you do enough breadboarding, I think the guarantee to success is much, much higher, because now you've proven the circuit, and now it's just your own limitation as to if you can pull that off. And there are instances where you're like, I could just use the wire here. Like, why am I torturing myself to bend this little thing? But that's part of the fun and the challenge. It's a puzzle. It's an art form, and it's therapy. Yes.
Have you considered combining it with like the kind of work that Arthur Ganson does with wire to make mechanical sculptures?
Yes, that has been the final frontier for me. I did create one bobblehead, but that's the next step. Kinematic sculptures, being able to use motion, because again, this is just begging to be animated instead of being static. So I feel like I have pushed it as far as I can with bringing out a personality of a sculpture through just shapes and forms. But I think motion would be, and then music. Like I am the opposite of talented when it comes to music, and so being able to create electronic music, breathing music would be very cool. I'm just gonna there's one person in the back.
So all of these seem very similar size.
Yes.
You thought about going like way smaller or way bigger?
So there's a reason why these sculptures are the size. One is the size of my apartment, and and the time I have at my hand. I have noticed, and I've said this time and again, if I take on a much bigger project that spans more than 2 weekends, it never gets completed. And so I force myself to make small enough, simple enough sculptures that can be finished. Otherwise, they are just an idea in a book. But eventually, maybe I'll want to modularize the design in such a way I can combine those together. And I just turned 40. And I don't think I can go any smaller. My eyesight is just not there anymore, unfortunately. But yeah, palm size. Being able to hold in one hand, I think that's the ideal size for me. Ali?
So the design also is within the 2 weekends? It's the build and the design in the 2 weekends?
Yes, thank you for that
Wow.
question. Yes, no. The build is 2 weekends. The design is maybe 2 years. Like there are these notes in my, like I usually use an idea binder and then categorize ideas, and I can fetch ideas way back from 2018. And so something that has been, forming in my head. And then I hate coding, but you have to code, and so the coding takes a very long time to get it right, and then the actual build part then comes pretty quickly.
Anyone else? All right.
Right.
Well, it was time to end anyway. Good.
Thank you so much.
That was amazing. That was amazing. Thank you so much.